This is a spacecraft that will land Chinese astronauts on the moon in this decade. At least that's what the nation's space agency has claimed, and they are backing that up with a recent test of the vehicle's takeoff and landing system. They call this the Lunar, which means embracing the moon, and it definitely looks like a moon lander. They've apparently taken some inspiration from NASA's Apollo-era lunar module. Here's a photo of the Chinese lander with some people around it for scale. Pretty familiar size and proportions, although they've made some big changes to the propulsion system. The Apollo LM was like two vehicles in one, a descent and landing platform on the bottom and an ascent stage on the top. So when it came time to go home, the astronauts blasted off and left their landing gear behind. Looking at this new Chinese test, it's clear that the lander is a single stage for both touchdown and takeoff. Here's the clearest video we have from one of the landing runs, shot at night so you can see the engines clearly. There are 4 main thrusters circling the crew compartment. Then we've got an outer ring of reaction control jets around the landing legs that are responsible for stability. Again, that's very different from Apollo, which had one big landing engine in the middle and RCS thrusters located up near the top. Chinese officials have said the lander has multiple engines that are arranged in a redundant configuration to back up each other. In the event of a single failure, the remaining engines can safely bring the astronauts back to lunar orbit. Now, what about this giant rig of metal towers and cables surrounding the vehicle? Well, I think there are 2 things we can gather. 1, this is to make sure the lander doesn't accidentally crash. That's fair. And 2, this would be helping them to simulate lunar gravity and atmospheric conditions. Moon gravity is 1/6 of Earth gravity, so it would make sense that the cables are supporting about 85% of the lander's weight during the test. It's probably also canceling out interference from the wind, which doesn't exist on the moon. So it's a pretty clever rig. We know that they also used this setup to test the Tianwen-1 Mars lander several years ago. As far as we can tell, the whole operation was successful, although the Chinese didn't release any specific milestones they were hoping to achieve or comment on how this fits into their lunar landing timelines. What we do know is that China wants to put their people on the moon before the year 2030. The Lunar is a big part of that mission, but it's also just one of many new designs that the Chinese are rushing to complete in this decade. There's also the Chang'e spacecraft. This is what will transport the crew from the surface of the Earth to lunar orbit and then back again. China tested their first prototype of this vehicle back in June with a suborbital launch and a test fire of the capsule's abort system. Unlike the old Apollo system, China's moon mission will launch on 2 separate rockets, one for Lunar and one for Chang'e. Then the spacecraft will meet up in lunar orbit. The rocket being developed for that job will be the Long March 10A. It's a triple-core booster with each of the 3 rockets being powered by 7 liquid-fueled engines. So it's very similar to a SpaceX Falcon Heavy in terms of look and function. China is expected to attempt their first launch of a single-core Long March 10A within the next year. We have already seen the first design prototype for China's lunar EVA suit, the Wangyu, which was revealed about 1 year ago. And the final piece of the puzzle would be the lunar rover Tianzuo, which will essentially just be an electric dune buggy. That's probably the easiest part of the whole mission. So the Chinese are making progress, that is undeniable. But speed is not everything. They also have to be making stuff that actually works, and so far, they seem to be doing okay in that regard as well. Now, is it enough to get people all the way to the moon and bring them home safely in this decade? We'll have to see. Talking about ambitious timelines, Rocket Lab's CEO Peter Beck just told investors that he's still pushing for the first launch of the company's Neutron rocket in 2025. Neutron is Rocket Lab's first fully reusable booster design, and it's a massive step up from their vehicle, the Electron. While Electron has proven to be an incredibly reliable little rocket with 65 successful flights out of 69 launches, it's only capable of putting about 300 kilograms into low Earth orbit. But it's also allowed Rocket Lab to experiment with some innovative new technology. The Electron booster is made of carbon fiber, and it's powered by 9 Rutherford engines that are manufactured using 3D printing. They're also the first rocket engines to run on electric fuel pumps and lithium battery packs. Neutron represents the company's first giant leap forward. It's not only a much bigger and more powerful rocket, but it's also a fully reusable booster that will be capable of propulsive landing on a ground-based pad or a floating platform. They also have this really innovative design for a reusable cargo fairing where it just opens and closes like a clamshell and then returns to Earth still attached to the booster. Just last week, Rocket Lab conducted their first hot fire test of the new Archimedes engine. CEO Peter Beck stressed that this was not a prototype or a test candidate, but a flight-ready engine that was taken up to full power for a long-duration burn. He also said, from here, it is about dialing the engine in, building a bunch more of them, and getting them rolling off the production line. Beck also said that Neutron is still on track for an end-of-year launch, assuming that every single thing continues to go right for the company. But he also made it clear that mission success is taking a much higher priority than timelines. On the company's earnings call last week, he said, "We are not going to rush and take stupid risks to get a launch of Neutron before it's ready. In the context of the life cycle of the vehicle and the program, a couple of months here or there is completely irrelevant." He added that there will be no cutting corners here to just rush to the pad for an arbitrary deadline. Potentially a little dig at SpaceX there, who launched their Starship rocket for the first time on 4/20, totally by coincidence, and ended up blasting a hole in the ground where their launch pad used to be, and then went on to experience numerous engine failures before eventually spinning out of control in mid-air for about a minute and then blowing up. Elon Musk called that a successful test for Starship, which Peter Beck also addressed in a much less subtle tone, saying, "You're not going to hear some rubbish about how just clearing the pad is a success. For us, a successful launch of Neutron will be successfully getting to orbit." Although the booster return is going to have a little more leeway, the best case scenario that Rocket Lab is planning for would be a soft splashdown of the booster in the Atlantic Ocean. Beck admits that landing the first stage is going to be a learning experience. Neutron also has a very unique launch site. Rocket Lab just completed their new launch complex on Wallops Island in the state of Virginia. It's well north of America's main spaceport at Cape Canaveral, Florida, and Rocket Lab says that this decision was made intentionally. It's a move to reduce bottlenecks in U.S. launch capability and introduce some diversity into their launch sites. If anything catastrophic ever happened at Cape Canaveral, there would essentially be no U.S. space program until that got fixed. And speaking of national security, Rocket Lab is currently eyeing up a big opportunity for Neutron to participate in the new Golden Dome missile defense network. Peter Beck said the $175 billion Golden Dome program could prove to be one of DoD's largest procurements to date, and we are in a great position to capitalize on opportunities here. So it's no coincidence that Rocket Lab just acquired a company called Geost in a $275 million deal that included $125 million in cash and the rest paid in Rocket Lab stock. Geost has been making technology that supports missile warning and tracking in addition to surveillance, Earth observation, and space domain awareness. So that ticks all of the boxes for Trump's Golden Dome, meaning that Rocket Lab is in a position to supply both the launch vehicle and the orbital platform technology, a one-stop shop for space-based defense strategy. And Beck even has a military application for Rocket Lab that leans more into the offensive side of weapons technology. Instead of retiring Electron, Beck wants to repurpose it into a missile. They call this the Hypersonic Accelerator Suborbital Test Electron, or HASTE, and it was tested for the first time in June. The company wouldn't disclose what payload it was carrying or provide the rocket's speed and altitude data, but they did say that the test was successful in whatever it was trying to achieve. In this configuration, Electron can carry a 700-kilogram payload on a suborbital trajectory, which means that it's going to land somewhere else in the world. Now, what exactly would they want to carry to the other side of the Earth? A bomb, a supply drop, some kind of Terminator-level AI robot weapons platform? We don't know, but it's definitely an interesting pivot in the Rocket Lab business model, and it shows that they are up to something big. So